Okay, so looking at question 6, we have 4-point charges of equal magnitude are held at the corners of a square shown in this figure. Which arrow shows the direction of the resultant electric field strength at the center of the square due to the 4-point charges? So we are interested in the direction of the resultant electric field strength. So we are not really interested in the magnitude of that electric field strength. We just need the direction. So you have to know that if you want to get the direction of the electric field strength due to a positive charge, it always points away from that positive charge, and due to a negative charge, it always points towards the negative charge. So that's the first thing you have to note. So what happens is that let me just redraw everything like this. Okay, now this is my center. You realize that if I want to find the direction of the electric field strength due to minus q, like I said, since minus q is negative, it's going to point towards minus q. So you're going to have something pointing like this in this direction. Okay, you're going to have something pointing like that in that direction. Now let us do for this q that is here. Now since that q that is there is a positive charge, it points away from the positive charge. All right, so for that guy is going to be pointing away from the positive charge. So this is how it is going to be. So it therefore means that the direction for the two charges that are diagonal, that's for these two charges, will here's the center, is going to be actually be in this direction. Okay, that's the resultant in for those two charges is going to be in this direction. Now what about these other two charges this way? Now since this guy here is minus q, that's this guy here is minus q, is going to be pointing towards it, so it's going to be pointing down. And then this guy up here is plus q, is going to be pointing away from it. So it means that the resultant is going to be pointing towards minus q. So this gives us the direction of the electric field strength in the system. But now we need the direction of the resultant electric field strength. Okay, so the resultant electric field strength normally has to definitely be in this direction. Why? Because of the fact that this is the center of the square. Okay, this is a diagonal. Okay, and this is another diagonal, which means that the angle between the two diagonals is basically 90 degrees. Okay, because if I complete it and I complete it, if I draw a line like this is going to be 45 degrees here, 45 degrees here, and 90 degrees here. Here 45 degrees, here 90 degrees, here 45 degrees. So the total angle here is 90 degrees, and it is the same as the total angle here, which is 90 degrees. Therefore, the resultant has to divide that 90 degrees into two, because the two components have equal magnitudes. Okay, so the resultant is going to be perfectly horizontal, because the magnitude of this component is the same as the magnitude of this component, because the magnitude of all the charges are the same. If you take the magnitude of negative q, you have positive q. If you take the magnitude of positive q, you have positive q. So since the magnitude of the electric field strength in those directions are the same, it therefore means that the resultant electric field strength is going to act at the center. So it's going to be perfectly horizontal. So option B is correct.